So how's it going, everybody? I am Adam, K6ARK, and let's see here. Give this a try. There we go. Who is K6ARK? I am a mechanical engineer by degree and a quality manager by day at an industrial facility. And in general, I see the wizardry that many of you guys do with these RF circuits and electronics, and it's amazing to me. I dabble in that and have some fun with it, but it's amazing to see what you guys do. One of my favorite parts of the hobby is the antenna side of things, and that's a great outlet for my strengths in this. In addition to that, I am what is often referred to as a content creator. I make videos for YouTube under the K6ARK portable radio channel. And I generally just say I'm a geek with a camera that goes and plays in the mountains and builds projects and tries to inspire some of you guys to do some of the same things. So in addition to that, in my spare time, I'm a climber, a backpacker, a mountaineer, and a SAR member. And if there's one thing I'm really good at in life, it's trying to cram far too many things into far too little time. So what I find is that when I try to get more of one thing in life, I have to sacrifice some other things and cut back on certain things to gain more on another. And the same really holds true with antenna designs. And that's what I'm going to talk a little bit about today, is extreme but practical and really useful versions of some of our antennas. And there's kind of a slew of antennas that I'm showing in the photos here. On the left would be a multi-band Yagi, a tri-bander, where you're really optimizing your gain, your efficiency, your directivity, and sacrificing on size. It's obviously something huge that you're not probably going to bring out portable. In the middle is your Ciro Mazzoni mag loop, which optimizes size from a small perspective, but maintains a high level of efficiency and has a very narrow bandwidth, the high Q that you're dealing with to gain those other benefits. And then finally, on the right-hand side, your chameleon M-Pass antenna, where you're trading off some efficiency for greater bandwidth and band hopping capability. I learned a lot about compromise in radio when I first became a general class operator about 10 years ago. And as an apartment dweller at the time, I didn't have a whole lot of options for solid antennas. So I took up portable operating. And the first video, first ham radio related video that I posted on YouTube was the one that I took a screenshot of here, where I'm showing an FT817 portable kit I had put together that it weighed about 5 pounds. And I thought it was great. I thought it was the smallest, lightest thing that I could take out into the wilderness. And if you were here last year, you're well aware that my perception has evolved a little bit. Things got smaller and smaller. And the same kind of held true for my antenna designs that went with these kits. I started out building dipoles and other wire antennas, some delta loops in the mix. Eventually, I realized, hey, if I use an end-fed half-wave antenna, I don't need to carry coax, and that cuts down on my bulk and my weight. And eventually, I've gotten to the point where this is my backcountry radio kit: the power supply, the radio, the antenna, everything in a 6-ounce package that fits in a little camera case. Mountain Topper MTR2B and a tiny little end-fed half-wave. And it took a while to get there. I've built just about every HF antenna I've ever used, except for this one. About 7 or 8 years ago, I bought Par Enfed's trail-friendly antenna, 3.5 ounces, tiny little package. And I thought it was the greatest thing since sliced bread. I said, I really want to spend 90 bucks on this antenna. I can build, an end-fed half-wave for 10 bucks. But I can't make it that size. I can't make it that small. I can't make it that good of a package. So I bought it, used it for many years, and had some great experience with it. But I kept tinkering, and I kept building, and kept experimenting. And one day on the workbench, I had a BNC connector, a solder window BNC connector, and a piece of wire and an FT50-43 toroid sitting there. I just set one on the other and I thought, wait a minute, this could work pretty good. I'll bet I could make this into a matching unit. So got to work with the Dremel. I enlarged the solder window a little bit, made room for a tiny little surface mount capacitor in there. I think it's a 0805 size capacitor, soldered into the BNC connector and shunt across the input. I wound a 49-to-1, 3-to-21 turn transformer, excuse me, onto the FT50-43 toroid, and I soldered it together, stuck the wire, the radiating wire down through the center coax point and connected it down to the output of the transformer, and the mini matching unit was born. I put a piece of heat shrink on it, potted it with an epoxy, and it worked really well. I made a couple of YouTube videos on how to build these things, and made a 9-to-1 unun version as well. Many people built them from those original instructions, but it was pretty difficult. You know, it was very small parts and really hard to get those pieces soldered together. So one day, a Summits on the Air friend, Matt N7MCB, sent me a message with a photo and said, hey, have you ever thought about using a PCB to make this build easier? I came up with this idea to create this PCB, and he sent me this photo that's on the left side of the image here. And I said, Matt, that's a great idea. Do you mind if I take that and run with it? So he said, no problem at all. So I took that idea and I developed the PCB further, and I've evolved it to the design you see on the right half of the screen here, which has a number of pads on it. On the bottom side of the PCB, you'll see a couple of square pads for a small surface mount capacitor for the end-fed half-wave build. And the through-hole pads, the smaller ones, are for inputs and outputs of the antenna wire, the counterpoise, if you choose to use one. A jumper set of pads that you can solder across to connect the counterpoise pad to ground. And then an additional pad that makes it easier to build it also as just a 1-to-1 common mode choke version. So, so these kits, which I sell now through Amazon, have this PCB in them and the materials you need to build it either as a 1-to-1, a 9-to-1, or a 49-to-1 end-fed half-wave matching unit. And they all package up into that tiny little size to make an antenna that looks like this. It's about the width of the palm of your hand. It weighs about an ounce. And this is about 66 feet of wire, 40-meter half-wave of wire. And with the little coil on there, loading coil to kind of compensate for end effect, it brings in 20, 15, and 10 meters as well with that same piece of wire. So I went from that PAR end-feds matching unit to continue to tinker and push those extremes of size and trade off that size or trade off that design down to what I was able to make as the smallest possible end-fed half-wave. Compromises here. Well, you know, to gain a very small, lightweight unit and you know, still maintain some of that multi-band functionality, I compromised a little bit with some transformer loss in here. A FT50-43 toroid in a matching unit isn't the most efficient thing out there, but it's not so bad that it's not usable. AI6XG, Dan, did some fantastic testing, and I encourage you to go check out his website. That's where this plot is from. He tested a 3-to-27 turn version on these toroids and found that you get about 1 to 1.5 dB of loss, which isn't great, but it's manageable. And the trade-off to have a package that ends up this small to fit in your portable pack is a pretty marvelous thing. So not every summit that I end up on has room to string out 66 feet of wire. And in that, I wanted to come up with an option for an antenna to deal with really limited space on a summit. Base-loaded verticals are an option, but I went down the road of experimenting with magnetic loop antennas, or small transmitting loops. And the common versions of these, particularly the portable ones, are the Alex loop antennas. And if any of you are familiar with those, they involve using the outer shield of some coax, usually roughly ½ diameter, kind of LMR 400 size coax, as the radiating conductive outer loop of the small transmitting loop antenna. And the smaller coupling loop up at the top there, and a tuning capacitor box down at the bottom. That's the common portable design. If you really want to optimize efficiency, you need a larger diameter conductor with really minimal resistance throughout, because that's what's going to eat up a lot of your efficiency in this antenna. But those just, they're not portable. I can't carry that 20 miles into the backcountry up to a summit in a 15 or 20 liter backpack. So I started thinking about, how can I make a loop, a small conductive loop that's decently efficient, decent diameter or surface area for efficiency, and still make it packable. I wanted to avoid having some kind of a frame that I had to build to hold it up. So I wanted a self-supporting loop. I thought about an example like, the wind shades or the windshield shades you put up in your car with that spring steel, they kind of pop open. I thought about those and couldn't find the right size, and I knew the conductivity of the steel just wasn't all that great. So the next idea or option I came up with was using a tent pole. So I bought a cheap aftermarket spare set of tent poles. I took them and carefully bent them a little further than normal into a loop, breaking some of them in the process because these are heat treated and kind of brittle. Bent them into a loop, put the shock cord back inside, so they all shock cord together, and ended up with a loop that self-supports. This whole thing weighs, I think this is less than a pound. There's me on a summit with it. And the way, let's see, so I used a smaller wire loop for coupling at the top here. And when I originally made this design, I simply had a large air variable capacitor, I think about 160 or 200 picofarad down at the base here for tuning. And what I found and learned very quickly when I got to the point where I could start tuning with it was that I needed a lot more sensitivity in my tuning, because a degree of turn would shoot across the entire band. But before I even got there, and another thing that's worth mentioning on these, when I first bent this into a loop, attached the capacitor, and tried to test this thing, it didn't even work. And what I learned really fast was that the anodized coating on these tent poles is non-conductive. So every one of these connections, I had a nice little insulating joint with at least a little bit of capacitance to it, but a nice insulating joint there. And with the need for good low resistance across your entire loop on this, it just flat out didn't work. So I didn't have a good way to solve that at this point in construction by removing any of those little ferrules and grinding off the coating, reassembling things. So what I did, I drilled some small holes at each of these joints on the open ends, the female end. I took a Dremel with some sandpaper on it and just sanded off the anodized coating on the inside. I sanded it off of the outside of the ferrule, but I needed to figure out how to get the ferrule conductive to the piece of tubing that it was fixed in. So to do that, I simply drilled a hole on each of these, placed an aluminum rivet in there with a little bit of dielectric grease to help prevent corrosion and things, and crimped that thing down in there. And what I ended up with was good enough conductivity to make the thing work. But back to the problem of the capacitor, right? I needed a tuning method that would give me sufficient fine tuning to be able to accurately tune across the band. And my first idea for that was to simply take two capacitors in parallel, one larger capacitor and one very small, say 5 picofarad capacitor for the fine tuning range. So I'd have one for coarse tuning and one for fine tuning. And that worked okay, but it wasn't the smallest option there. There you can see the single air variable capacitor on my maiden voyage of this thing. So what I came up with in the end was a different solution. I said, well, you know, if rather than having a large air variable capacitor, why not instead put some fixed capacitors in there on a switch? And that fixed capacitor will get me into range for the band. And then I'll use a small air variable. In this case, the small air variable is here on the end to fine tune across the band. So to first achieve that, I had to figure out what value of fixed capacitor I needed. So I took an air variable and soldered a couple of alligator clips onto it, attached that to the loop, tuned the loop, and then pulled the air variable capacitor off, measured the capacitance on this, and simply built some fixed capacitors to put in its place. The first iteration of that was with just some standard ceramic capacitors there. And I quickly learned that those are not temperature stable enough with RF flowing through them to give me a consistent response there. And after that initial failure, I moved on to some silver mica capacitors, some 1,000-volt varieties that I placed in parallel across 4 different switches, for which I could take combinations of those switches to bring me into every band from 40 to 10 meters. So that's what ended up on this loop. But clearly this is still too big and too heavy, right? I mean, if you've learned anything from me presenting at 4 Days in May, I always want to make things smaller. So seeing some of VK3YE, Peter Parker's videos, he's got a number of magnetic loop or small transmitting loop antennas that he's built out of bar stock aluminum, some of the aluminum bar that was shown in the last presentation. And I said, you know, if I get the right size of that aluminum bar, and it turns out it's, for me, it was 1/2 inch by 1/16 inch, and cut it into sections that are hooked together by fasteners with nylock nuts. I can accordion fold those down to a very small size and accordion them out, bend it into a circle, and end up with, again, a self-supporting loop. So this larger one has a 3-position switch that I built for use with a Mountain Topper MTR 3B. So it'll do 20, 30, and 40 meters. And it weighs, I think this one's about 9 ounces. And this last small one here that I just showed you is a 1 meter in diameter. So it's a smaller size loop. It packs down to, what is this, about 9 inches long. And it does 15 meters only. But the kind of unique and fun thing about this one is that the BNC connector is directly attached to the bottom here. And this is light enough at 6 ounces to just place it on top of a KX2 and use it like a handheld. So it's a fun little unit. Again, fixed capacitors inside with a small air variable, this time in a little 3D printed case there. So let's see. I've got a video here talking compromise on this. The big trade-off with these, yeah, we're gaining very small size and packability, a tiny footprint on a mountaintop, but with small transmitting loop antennas, especially as you get a smaller loop and lower bands, you're trading off a lot from an efficiency standpoint. And you know, as you can see from my designs, these are certainly not optimized to minimize your loop resistance here with all these accordion joints. So I know and accept almost to an extreme that I'm taking some serious losses here on efficiency, but still it'll work. So let's check out the video here.
Japan on 40 meters. There you go. All right, I guess maybe the same isn't that on 40. What the heck, man? That's insane. I've never gotten Japan on 40 before. And here we are sitting here running 5 watts with that little magnetic loop, and we just got Japan. Let's keep going. That was awesome.
All right. Andy, microphone back. Oh, there it is. Cool. All right. So so you can see, you know, that the band gods were certainly in my favor that day. The reality of this efficiency on 40 meters has got to be in the single-digit percentages. It's not much. JG0AWE was running 50 watts in a dipole that day. He's a regular soda chaser and a really solid operator there. But it was pretty cool to get some proof that this works. And in the photo here, you can also see how I set this up. It's sitting on a trekking pole there. I set up an upside down trekking pole that fits right into a socket on the base of the loop. So I don't have to carry anything extra to just support the loop out in the field. So, you know, sometimes it's okay to make trade-offs for packable size, also packable size or summit footprint in exchange for some losses in efficiency. And there are other times where you really want to maximize your antenna efficiency or gain or performance for, you know, say working DX, for example. And so I've gone down the road of exploring that side of the extremes as well. There we go. I started out for a gain antenna, I started out with a half square, which is a pretty common portable antenna for decent DX performance. It looks like a U, right? Half a wavelength across the top. It's basically 2 phased inverted ground plane verticals. And from that, you get pretty good broadside gain and decent low angle irradiation, especially if you're over decent ground or perhaps on a mountaintop where the terrain drops away really well. That'll help with the angle of radiation as well. And this contact map here is from a SOTA activation where I stayed overnight on a summit, ran 20 meters with the half square, and worked a whole bunch of Australian contacts, New Zealand, Japan, Europe, all over the US. I think I was actually pretty close to working all states from that SOTA summit, believe it or not. And the half square performs pretty well, but I wanted more. So here's the example of the half square from an MMANA antenna plot perspective. you get about 1.9 dBi at 10-degree angle, which is kind of your DX spot there for 20 meters, and a peak gain of 3.8 dBi per the modeling over simulated real ground. So I said, well, what's the next step up from a half square, a bobtail curtain, right? Just add one more element, make it that much bigger. But what I realized pretty quick was that you don't really get much more out of just adding that extra element on a bobtail curtain. You get a narrower pattern, and you only jump up to 5.16 dBi, which really isn't that much extra gain. So I started tinkering around a bit more with different modeling, and what I realized was that if I create a second bobtail curtain acting as a passive element and place it a fifth of a wavelength behind, or 0.2 lambda behind the driven bobtail, you end up with quite a directional antenna with significantly better peak gain, 8.45 dBi over that 3.8 or whatever it was for the half square. So I said, heck, this is actually a viable option for a directional gain antenna. And if you want to compare the three antennas, you've got, I think it's in the blue there, the innermost rings there, that's the half square. And then the slightly larger one, the red around it, is the single bobtail curtain antenna. And then the green on the outer end here with the directional lobes is what I call the double bobtail. I searched around, I wasn't able to find anyone else that had made this. So I'm curious if anyone has seen this before, please reach out to me and let me know. I'm curious to see what others have done with this in the past. Someone has to have done this at some point. And what was really interesting to me too was that I didn't need different dimensions for these bobtails for whatever reason. And I don't fully understand the wizardry behind that, but I accepted the modeling at face value. Perhaps it's incorrect, but it does seem to work in the field. And what I did in building this and setting it up was I created it such that I can easily swap directions 180 degrees by just moving the feed point of the antenna to the different bobtail. And the other sort of nice thing about this is that I can support this whole antenna. Well, it packs up small in 26 gauge polystealth form. This is both bobtails on this right here. I've got a matching unit that I didn't bring with me, but it fits in the palm of my hand, a 100-watt capable 49-to-1 matching unit. And then you just need four telescopic poles, ideally ones that are non-conductive. I think it was Rick mentioned earlier an experience with using carbon fiber in close proximity to touching a radiating element. And so these are fiberglass poles, so I can simply place them vertical along the ends of the antenna there. I support it from the ends, from the corners there, and then feed it from the bottom center of one of the elements. And to support the matching unit, I use one of those little fiberglass sticks that you use as a driveway marker. It's nice and light and non-conductive and holds it up about 1 meter off the ground. So taking the double bobtail out, there's the side view plots of these again. Taking the double bobtail out, I wanted to get it out in the field and made a contact with someone in the back there who's visiting all the way from Tasmania. Give Hayden VK7H a quick round of applause there. Hayden also has a fantastic YouTube channel. And I made a scheduled contact with Hayden from his home QTH there from Southern California. This was before the solar cycle really picked up. So 15 meters was not in great shape at the time. So let's take a quick look at the video here. Is Andy available there? Thank you, Andy.
Victor Kilo 7 Hotel VK7HH VK7HH from Kilo 6 Alpha Romeo Kilo. Kilo 6 Alpha, Romeo Kilo. Roger, Roger, I copy 4-1. You are 4-2, 4-2, 4-2, 42 QSL. Awesome. Yay, we did it. Very cool. Thank you. Thank you in 7-3. Thank you in 7-3. We got Hayden. That was awesome. VK7HH in the log.
So admittedly, we were cheating a little bit there, running 100 watts, but that's what the conditions warranted for that day. I've since brought that out and worked at QRP. I used that antenna for the transatlantic soda QSO party that we had in, I think, last November. And I was able to work 3 European soda stations summit to summit on 15-meter CW with that antenna, which was pretty darn cool. Compromises on this thing. Well, it certainly provides significant gain, which is a big benefit. It's got decent low angle radiation and rejection off the backside. It's relatively compact and light-ish. You know, these 4 telescopic poles and some extra stakes aren't too heavy to carry up to a summit in the backcountry. But it is monobanded. It does require 4 poles as supports. And really the biggest drawback with this is the directionality and the steerability of it, right? I can easily swap 180 degrees, but I certainly can't steer it to point toward a signal that may be coming from the side at any given time. It takes a significant amount of time to be able to change that kind of direction. There we go. So that, 8 point whatever dBi obviously still wasn't enough gain. And I wanted some steerability and directionality in my directionality of the antenna. So I started tinkering with the obvious solution for that, a portable Yagi, right? For HF, why not? Seems feasible. So the first design started out with using these very similar poles to these 16-foot poles that I had, fiberglass poles. And I assembled them with a hub that I welded out of fence post top rail that these poles nicely slid into. And I oriented them slightly rectangular, kind of a rectangular X at the center to support the wires. Along the sides, I ran some low stretch cord from end to end and created some loops that I could connect wires running across to, and ended up designing and building a 4-element 10-meter Yagi with straight elements. The mechanical design with this was a little bit of a challenge. I had to use very light wire, 26 gauge, for the wires to really prevent them from sagging too much. But I was able to get it assembled, brought it out to a summit for, I think it was the ARRL 10-meter contest, and set it up and had a heck of a lot of fun operating up there. Oops. See if that'll play, Andy. There we go.
And I found a good spot that drops away to the south and to the east. So it'll hopefully help with the takeoff angle here. So I'm going to get this monstrosity set up. This is what it looks like all packed up. So 4 16-foot poles, these black ones. The blue is a telescopic pole cleaning pole that is my mast. Center upright support for the guy lines at the centers, all the wires and guy lines, and the center hub with my little 12-volt motor rotator here. So we'll see how this works. There's some light wind, and I may have to just lock up the rotator because it tends to slip in the wind. But we'll see. So let's get her set up and see what happens.
So this is a nice local soda summit, real to my house in San Diego. Maybe a 2.25 mile hike to the summit, 1,200 feet of gain. So it's not too bad. It's reasonable to bring a 30-pound pack up there for a day like this. Yeah, this is it takes about 30 minutes to set up, but it's actually not too bad. The guy lines for the mat is wedged down in the cracks of the rock there.
Well, there it is, folks. 10-meter 4-element beam on a mountaintop. I'm not gonna lie, this is a little bit ridiculous, but hopefully it'll work. So, yeah.
So let's see. Are we back on here, Andy? No worries. There we go. That was not me playing, but it worked pretty well. It was definitely directional. My design was not all that well optimized on this thing, and I ended up with not a very good front to back ratio. I've since learned a bit more about Yagi design and modeling those and figuring out how to optimize those. But it certainly worked, and I made a lot of contacts in a few hours on sideband down to South America. Again, this was a few years ago, and 10 meters wasn't open quite like it more consistently is now. But made some great contacts, and that little 12-volt rotator was a heck of a lot of fun. But clearly, that still wasn't enough gain. So I went to work again and took some cues from the spider beam Yagi designs, the bent element spider beam Yagis, and used some slightly longer poles. I found some poles that claimed to be 7.2 meters, but when I kind of worked my magic to strengthen up the really thin tip section and glue it into the second section and things like that, they end up being about 18 feet. I made a new center hub. Now I have a 3D printer, which opens a whole new world of tinkering and design. And this is, I think I've got a picture of it here. Yeah. So this is another 12-volt rotator. And my intent is to kind of finalize this design, share a bill of materials and STLs on printables for anyone that is interested in building something like this, because these things are super handy. It's a simple 3 RPM 12-volt DC motor that does produce some nice noise, as we observed earlier in the day while it's running. But it's, fortunately, it's not running most of the time you're operating. And then I've got a 3-to-1 gear reduction drive, a belt drive on there, tooth belt, that brings it down to about a 1 RPM rotation, and just a DC double pole single throw switch, so I can run in forward and reverse direction to control this. Just run some wire up from my battery. This hub holds these 4 poles, as well as a center riser pole. You can kind of see them in the left photo there, but that slips in the top, and these 4 poles slip into the sides here, kind of like that. And with the guy lines on this thing, this little 3D printed hub is actually plenty strong to support that. So as I mentioned, I learned a bit about Yagi design and modeling, and still I wouldn't say this is an optimized design. It should probably have 6 instead of 7 elements for a 36-foot-ish boom, and I could probably squeeze a bit more gain out of this and get rid of some of those side lobes. But what I ended up with is about over 10 dBi free space gain on this Yagi. So over real ground, I'm probably getting 15 or so dBi of forward gain and pretty decent performance. You can see the whole system there and everything involved in it. This is the bag of all the wires, the impedance matching section, quarter wave section of 35 ohm-ish coax that I made out of some other parallel coax to match the impedance of the antenna. All the wires for the elements are in here, and also all the guy lines for this. And there it is set up in the front yard. It's probably going to be a little bit hard to see there, but suffice it to say that there are a bunch of Spectra fishing line guy wires that run from the tips to the elements near the center, which are 18 gauge poly stealth wire. I went with a little bit larger wire because I was able to on this one to try to help with that efficiency and bandwidth and performance. And this is a very recent build. I've made a total of 1 contact on this antenna, and it's here on video. This was at the ham radio crash course camp out in San Diego a few weeks ago. So let's go ahead and play the video there.
Kilo 6 Alpha Romeo Kilo. Alpha Romeo Kilo. Alpha Romeo Kilo. Go. So Kilo 6 Alpha Romeo Kilo. K6ARK. Right. And and that's on a 45-foot bird. That's pretty good. 5 but on a 45-foot bird, it's a big ass dinner. It's quite high, about 35 feet. I'm trying to figure it out in the Workbench. I'm running a week before they're doing 90 watts. That's what we throw at it, okay?
So I was running 90 watts there. Get the mic back on. So I was running 90 watts there, again, not QRP. I tried running the KX2 earlier that day, and the band was just not in good shape that day. I wasn't making, it wasn't even hitting the reverse beacon network. So so the band wasn't really open in the morning. And then I tried again later in the day using a 100-watt station running at 90 watts there, and tuned up, heard ZL1WN, Ross, a pretty well-known operator that is constantly working US stations with his massive station down in New Zealand. And first call, made it through the pileup. Ross gave me a 5.7 signal report. He was peaking at about 10/9 with his probably kilowatt and even higher gain antenna pointed our direction. So I wanted a comparison of this. I wanted to know if it was really performing like I was hoping it would. And at the camp out there, Josh brought his Buddy Hex antenna. So I quickly ran over to the station there and I said, hey, Ross, ZL1WN is on this frequency. Somebody make a contact with him and see what signal report you get back. So we did that.
Kilo 6.
Andy, next.
Kilo 6 Alpha Romeo Kilo.
So let's go to this. So this is Tom. He was at the camp out as well. I said, hey, Tom, I need you to work New Zealand. We got to run a test here. We got to see if the Buddy Hex gets a better signal report than my monstrosity that we set up over here. So this is Tom making a contact with Ross.
Kilo November 6 India Papa Zulu. Kilo November 6 India Papa Zulu. QSL. Name's Tom over here in Southern California. Yeah, well, with a number of people calling, Difficult at times to work out the contact. Yeah. Yeah, make full contact, Senator.
All right, well, Tom just helped me out with the comparison here with the Buddy Hex, and I won. So he got a 5.5 on the signal report, pretty close. About I had 5.7 as the response, but
What was your power compared to his?
I was running 90 watts, so
Were you?
basically the same.
So now let's do it on 20 meters.
Go put it back up.
Josh, you're
What's 20 meters? Is that a band?
Yeah.
Oh, I'm gonna have to build another antenna. So I won the competition there. It's one comparison. It's probably not all that representative because of the way the band changes, but it sure made me feel good. And so in the end, the compromises with this antenna are, it does give you all the gain. It gives you the low angle radiation. It's sort of packable-ish enough. The whole setup, even with that telescopic pool cleaning pole, weighs less than 10 pounds, which is pretty amazing for a 7-element 10-meter Yagi. So it will certainly be out on some more summits in the future to play on 10 meters. The trade-offs there are the fact that it's monoband, as Josh nicely pointed out for me, and that it's just downright huge. It doesn't handle the wind well because it's an ultralight construction, and it's it's just big. So, but it's
Kilo November 6, India Papa Zulu.
Sorry about that. Next slide. So my challenge to you in what you all do with antenna building and projecting is to think outside the box. Don't let those bounds of the norms and the standards control the limits of where you go with your designs and what you create. Because if you push some of those elements to the extreme, sometimes you come up with some really cool things that truly are practical and useful in your portable or even home operating. So a couple photos here of just an even smaller version of the matching unit on an SMA connector and a little base-loaded vertical antenna that's 3D printed there. So I want to say thank you, especially to Andy and David Kripe and all the coordinators of 4 Days in May. You guys are awesome. You put on a wonderful event. And then just, of course, all of you for being here. My favorite thing about these Hamfests is just meeting all the awesome people, and I really appreciate it. So thank you. So we've got a few minutes for some questions here. I think Paula had her hand up. Yeah, good question, Paula. So Paula's asking about the rotator and the fact of how it probably can't handle a whole lot of wind. It certainly cannot handle significant wind. It's a fair weather rotator, we'll put it that way. But it's not too hard to just lock it up with some Velcro straps and use the Armstrong method, as we call it, for controlling direction of the antenna. So that's a pretty cool option there. I think you could also beef it up a little bit with just a little bit of extra weight to make a more capable rotator there. So good question. Thank you, Paul. In the back there. Yeah, great question. So for pretty much all of my prints, I use PETG. PETG is a little harder to work with than your standard PLA, but it has a higher melting temperature, so it's not going to distort and warp when I leave it in the back seat of my car on a hot day. It's also less brittle and a bit stronger, so it handles you know, some of the stresses a bit better. I'm sorry? Density of for infill. I do 100% infill on most of these prints. I'm pretty sure I did 100% on that rotator, but for things like that, you know, I need that hoop strength and layer adhesion to make it work. So.
When you had your double curtain antenna and then you put another element there, you were using the four fiber pole supports. Did you have any trouble with wind blowing those around? Anytime I've seen fiber poles like that, the tips get so tiny that trying to use it to seems like any amount of wind would just bother it.
Yeah, good question. So a few quick tips on telescopic poles. A lot of the poles you buy have a really thin, super light tip section that's not really usable. And a lot of people just take that out and throw it away. Rather than doing that, disassemble the pole, take out the two tip sections, and take the thinnest section, coat it in glue, and stick it back into the second section, and just leave it in the retracted position. And by doing that, you're just reinforcing that second section with that tip section that you would normally just throw away. And in that process, a lot of times what I'll do is also take there's often a little piece of cord at the end. I'll bend that back over and with tweezers, stick it back into the end of the pole and glue it in there so it becomes a loop. And that's an attachment point for me to use. So that makes a big difference. And then for guying of those poles, I've got a video on my channel of how I guy out the poles. And I typically just use the bottom most rigid section with 3 or 4 guy lines, bring them down at a 45-degree angle to stakes in the ground. And for most poles of kind of a moderate length, that's sufficient.
About like you have your 7 element beam or down.
Yep. Same idea. And then to keep the wires from blowing around, I'll take some extra stakes and some cord and just put a light amount of tension on the bottom of the wire of each wire to pull it down toward the ground so it can't move too much. And I maintain consistency in that position. Great question. I actually have one partially built and am tinkering with a W8JK build using those same poles, about I think 4-meter spacing between the two doublets. Very cool. Yeah, I'll talk to you a little later about that. I'm interested to hear more. Any other questions? Did I see a hand somewhere? I don't think so. So I will have all this stuff out at Homebrew Night, and I'd be happy to show you in more detail and get some hands on all of these things if you want to take a closer look. So thank you again. I appreciate you guys. And thanks, David, for having me here.